This is Prabhakar from Box Heroes. So this is my part 2 of how JavaScript works in browsers and in the server side as Node. And and also I talked about browser architecture. Basically, so how they all work together, come together. So this is what we talked about, having a runtime engine using stack, heap, web APIs along with callback queue and event loop. How it operates asynchronously and does not block your CPU bound operations. So, and if there are some operations that need networking or needs web API support, so like timer, etc., everything. So it happens on a separate asynchronous route, so that your main call stack is not blocked. So that is a very responsive mechanism for serving web requests. So we also talked about browser architecture, and I think this is so basically this is where the JSEngine lies, and how the user interface, browser engine, rendering engine, networking, UI backend, data persistence come together. So I touched upon all this, and also finally towards the end I showed how Node.js leverages on the V8 engine and uses a similar callback queue, so call stack and a callback queue, and non-blocking. So whatever blocking operations are there, they happen asynchronously for whatever IO bound operations, right? And other happens asynchronously, like database connections, file system, or calling a different service, HTTP fetch calls, etc. Everything, right? So it leverages on the same JS concepts. So, but in the front end we have, if you might know, that there are many JS frameworks that are out there. So we will wonder like how they actually help here, right? So they are quite complex, right? Some of them are like MVC background, like Angular model view controller, and so they provide some abstraction, right? So jQuery provided some abstraction over some of the complex JS implementations underneath, like doing network calls or doing some bulk operations, some complex group of operations. So you are able to simplify those operations. But then why do we need so it had some lot of simplification here, right? Then how does React Angular is the next level of abstraction? So what does this new abstraction level in the form of React Angular provide us, or Vue.js, right? Why is it needed? Just briefly to talk about myself before we continue. So my name is Prabhakar. So I have more than 10 years of experience in the software industry in different software areas and industry. So I have seen different sizes of companies, including startups and also large multinational companies. And to talk about technology, I've worked in Java, JavaScript, HTML, your Node, React, GraphQL, Python, IoT, backed by ML models, so AWS, large microservices operations, small but very complex microservices implementation for security kind of apps. So I have a wide range of interesting, you know, combination of experiences that I want to share through this channel. So I would be happy to try to bring it all together to you. I hope you will find it useful. So going forward with my presentation here about JS frameworks and how to leverage the working of JS fundamentals that we have talked about, the JS architecture, the JS design, okay, the event loop, particularly that comes up regularly in different discussions. So why do we need it? To come to that first, let's try to understand what React is. React is your it's like what you say. Mm, so it's so the concept of React basically lies on giving the developers the power to manage the view effectively. Okay, rather than think in terms of MVC, model view controller. So they mainly make the developers focus on the view. So because Facebook engineers normally they believe that the main focus of UI developers, the front end developers, should be the view. So they should be given the power to manage the view and think as less. So the idea of model, the data and the networking, etc., everything, and the interaction with JS frame, JavaScript infrastructure, JavaScript architecture, underlying architecture, should be something that should be abstracted. There should be more focus on how do you manage the view. So to support this, they focus on components. So breaking up the view into components. Okay. So now components themselves are an abstraction of traditional DOM elements, etc. Everything. So you can build on them and build more complex custom components. Okay. And using them, you can actually, also provide some better handling of state declaration, virtual DOM support, and Fibre architecture that is there. So it depends on components. It depends on state declaration of what state of the view do you want to achieve. So you can define your states. So it's a declarative mechanism. So from once, so it's just that you need to move from between states to modify your view, and depending on this modification of your state declaration, your DOM will get changed through something called virtual DOM. So this is a middle path that is taken here to aggregate your changes and then pass it on to your actual DOM, because actual DOM changes are expensive. Okay, and then so this is the Fibre architecture that came in React 16. So this is very fundamental to the whole effective working synchronization of rendering of your pages in React. So Fibre architecture mainly optimizes your changes. So basically prioritizes which changes can happen, batches them, aggregates them, and so in minimal steps, how can it make effective changes of your view. Okay, only what is required. Okay, rather than doing piece by piece of the actual DOM, so it does batch updates to the DOM. So this basically so this basically works around the event loop pass through. So we know that the event loop works. So when your stack is busy, then the event loop is not free. So event loop gets only free when your stack goes empty. So then the event loop looks back at a callback queue and then aggregates something new into the call stack, what was pushed, and then it works on them. And then after the call stack is again empty, then you have the what you call then you have the next pass through of the event loop. So after the call stack is empty, so it's a very expensive operation. So on every event loop, how can we make these changes effective, aggregate them and make them effectively, right? So it's very important. So that's why React is very effective, because it on one side it gives the developers the power to manage the view effectively, and on the background it actually managing the JavaScript interactions effectively with good understanding of the underlying JS architecture design, right? Most leveraging it to the fullest. So coming back to our presentation, so I will continue here now. So this is what it does. Traditionally, we actually via jQuery or traditional plain vanilla JavaScript, we directly change the DOM. So this we do piece by piece. We do on changes on the h1 element or some p element, paragraph element, etc., right, on the image element. So it's like step by step we do it piece by piece. So, and this is not a very optimized way of doing it. So instead what React provides is a virtual DOM you keep on modifying on the virtual DOM. Okay, it aggregates the changes here. It sees what is the effectively, it sees different the difference between from the components to what it is going to change to. So when you change the state, so you have a new like new DOM that is desired by you, by your app. So that is determined by determined by React through the virtual DOM. So its algorithm works on that the minimal changes that is required to achieve the new DOM. So once the event on every event loop pass, it aggregates those changes, finds the minimum mm, way of doing it, and changes to the DOM. Okay, and also on the other way around, if events are clicked on the actual DOM by the user, so it actually comes back to your via your virtual DOM to your actual app interactions. So and it goes back if the new state change happens. So so on and so forth. So that's how. So this virtual DOM of React actually abstracts away the actual DOM interactions. So that's a pretty effective way of effective strategy, if you may ask. So so that's what. So using your components, so that's what I said. If you use your the components not only determine to break up your view into smaller, defined custom parts, but it also helps to define the what you call the helps you to differentiate, calculate the difference between your the desired whatever changes you want to make to. So this is what designed to make calculating the DOM difference much more efficient. Okay, so so this is a pretty effective one. So let's move. So this I think we have covered. It's clear now. So the next part is so so that's so it happens on every pass. So it React reserves the right to say when the actual DOM changes will happen. So that's because it wants to optimize the interaction via the event loop passes and batch them. Okay, and calculate. So it basically calculates the minimum difference that needs to be applied effectively to the real DOM in few steps as possible to get to the desired output, desired rendering. Okay, so so that's so going to the next one. So so this is what it says. So it does not have exactly say when or how it will call render. Okay, so render it will again so React abstracts all these calls, so it optimizes the whole interaction with your real DOM. Okay, so we don't control it. So it is because React says that we know the interactions better, please let me handle it. You just focus on the view, you break up it into components the way you want it, and the rest leave the rest of the actual interaction with the DOM to me. Okay, I will manage the event looping passes. Okay, so when you set the state, right, so it basically sets when you set the state, so basically you do some parts of your component changes and your so you say this is, so virtual DOM says this con 30, so these some changes in this components tree, right, and this then you actually determines what changes are required, then it actually changes only that part rather than doing the whole tree. It finds the actual difference what needs to be done and does it. Okay, so that's why React is so effective in writing great apps. So and this is so this diagram actually explains the set state, how it works. So basically when you say set state, so after some time delay, whenever the event loop is free, so then you do the rendering, call the render. So it groups all the changes via event loop, batches them, and then via event loop calls the render. And after the render, it actually does the minimal changes that is required to the actual DOM. Okay, so there is also the thing of event handling in React. So even in event handling, what it does is that it is another costly mechanism to find if you actually do it on the directly on the actual DOM nodes. So it's slow when memory consuming. So instead, React uses a technique called event delegation, okay, which is effective. So it uses one event listener at the top of the document root element, and when the event is fired, the browser gives the target DOM node. So instead of passing going through the whole tree to on which DOM element the event happened to track it, so instead you actually it's reported to the top of the tree. So you listen from the top of the tree and you collected event handling, and uh, you can work on the trigger event trigger. So that's what. So one you do it, so you get the top level event handler, so that collects it, and the specific event handler in your app React Native code, you write it, and you trigger a set state. After some time you leave the event loop, the render gets called, and render decides what exact changes needs to be done to the DOM, and then you have update minimally. Okay, so that's how it works, set state and event handling together. Okay, so what we have learned from this. So one is that the DOM, the piece by piece change that we do traditionally, writing custom our own JavaScript code, is expensive. It is not an effective way. It requires more complex handling than just writing what we do in plain JavaScript. So instead, so if we do per event loop passes, if we do the batch operation, and basically the batch operations that matter also, only the minimum differences, it's more effective. So this what React knows best. I think we need to leave it to React. So one thing you need to understand is that when you call set state, it re-renders the whole subtree. So if we want to be performant, right, we need to call set state only when needed. That means we need to be stingy in calling set state. And also we need to call use should component update, use memo. This we need to use them, so that you need to minimize re-rendering of the large subtree. Okay, so this I think is a so it mainly the whole understanding how React works helps us to empathize with how to use set state and use memo should component update. Okay, so it's not fair to call set state every time we feel we need to call it effectively. Okay, so that's how it is here. And so we also learned that it aggregates the changes to DOM, the actual DOM. Okay, so which is a very crucial strategy, of course. And we should from what we understood from our last understanding, from our last conversations, last presentation, we understood that render engine and JSEngine run on the same. I mean the JSEngine, the event loop run the same thread. So you can understand, like yes, you need to be very observant of how to get the most performance out of this. So writing JavaScript code, plain code on ourselves is not the best suitable thing. Maybe in a very small application, maybe it is fine, but as you go on, you write is a complex app. So when you add a lot of things there, it actually does not work out anymore. Okay. So yes, so we should avoid heavy performance on the main thread. That's I think we discussed from part one itself, because if we do with some CPU bound operations on the main thread, like a long for loop or a very complex implementation, complex logic, say, okay, like data encryption, etc., right? CPU intensive operations, so it will block that operation. Instead, we should actually call a service that does the data encryption or does a complex operation. We should do asynchronous call, maybe a service, another service, right? Instead of depending on that blocking the main thread, instead we should allow it to pass through, call that asynchronous operation to something else, wait for it. Once it comes back, you can always pass it back. You can process it later. Okay. So Node.js suits very well when you do transformation, merging of request response, delegating operations. Okay, rather than doing compute intensive tasks. Okay, so for some narrow band of operations where some very compute intensive tasks are needed. Uh, okay, like encryption, decryption, so and so like machine learning algorithms, right, running them only. So those we cannot be should not be doing on the main thread. Okay, they should be outsourced to some other operation, so other service. Okay, so I think that covers the lot that I wanted to discuss. I hope this was helpful. But before going, I want to also cover what React 16 brought. So whatever we discussed, right, that batching, the synchronizing of that changes via the virtual DOM. So how effectively using the event loop pass through, right? So it comes from React 16, and the architecture's name is Fibre. It's called Fibre architecture. Okay, so it's pretty interesting. So the React Fiber, so you say it's a new conciliatory algorithm. So basically, it's comparing of old trees with a new tree in order to find what changed or modified. And actually, so it determines how to process those trees, component trees, in a single pass. How to do it in a single pass. So that the main thread, so this is what it does also, right? Ability to split interruptible work in chunks, ability to prioritize rebase and reuse work in progress. So ability to yield back and forth between parent and child to support layout in React, able to return multiple elements from render. So these are so complex concepts that is covered here. But so it's a different story altogether to go through all this. But what you should understand is what we discussed here is that this React Fiber actually helps us to batch the differences that need to be applied to the DOM, find the difference, batch those differences, and then on every event loop pass use a minimal difference applying to the DOM. So that's what it does. So this is the reconciliation algorithm, which is called React Fiber, that came in React 16, which makes React even better. Okay, so I love to work on React. It's a wonderful framework, JS framework, and I should, if you are new to it, you should definitely try it out. If you're already there, great, keep going. And yes, hope we'll meet sometime soon. Then I'll try to come up with something interesting very soon. So up till then, goodbye, cheers. And if you like this, please like, share, and subscribe. And if you have something to say, if you didn't like someone, please something, please share your comments. I will try. I will definitely love to improve on them. Uh, so yeah, let's catch up later then. Take care. Bye.